Hello everyone, and welcome back. Today I'm going to be showcasing some of the network transform synchronization that I'm doing within Unity and SpatialOS. Um, so one thing you'll see here, I'll have to be a little careful with what I show you here today, as there are systems which I'd like to not expose. However, I will show as much as I can. So right here we have an enemy just on a nav mesh with a custom AI component on the server side. So what you're seeing here is there's two workers essentially in this zone. There's the client worker and then the game logic worker, so essentially your server and your client. The client representation of this enemy here, if I can find it within the hierarchy, here we go. The client representation is just basically the animator, the model, and all the visual elements essentially. However, if we look at the game logic or the server side of this, we can see a bunch of custom editor components here. Now what you see in front of them, this is for the AI system that I'll go in more depth for in another video, but that's essentially his field of view, and there's a couple of other things as well. But we're looking at transform synchronization today. So as you can see there, perfect example, when he's wandering around, you can see the highlighted cylinder is the server worker. So it might look a little bit in front, and that's because it is the server is ahead of the client in a sense, because there's delay between the server and the client, of course. But the transfer and synchronization, as you can see here, when he's moving, it lerps the client to the server object, as you can see how far it is behind here. And also, if we were to do a lag simulation, this would also work very well, as well as it's using the whole correct tick rate and everything. It's all there. Now there's no prediction as of yet, or time dilation or anything like that. But there is a nice lerping position. And this is very performant as well, because it's not sending the direct float values of each X, Y, and Z. It's compressing it in a certain way, which I'd love to go over. However, I wouldn't like to expose too much, as this is a work in progress project. But yeah, as you can see, I'm moving the server around, the client follows. And if I were to move the client around, it would not follow, because its position is being updated by the server as we speak. So you can see the little animator component trying to get velocity there from the client to do the walking animation. However, we're not moving anywhere. Thanks for watching. I'd also just like to note one last thing actually before I go. There are better ways to do this system. However, this is the most simplistic way to get it up and running as soon as possible, essentially. So one thing you could do is synchronize the waypoints that the nav mesh agent has, and then get the nav mesh agent to go out there on the server, send different obstacles along the way, things like that, and sync a lot less data. However, this way is very performant. It sends barely any data between the server and the client, and it works very well and smooth. And so for now, this is what I'm using, and it works just fine. If you have any suggestions or anything, be sure to leave them down in the comments. But yeah, thanks for watching.